So I'll start the class now. So good evening, everyone. So welcome to the problem solving and doubt clarification session for the NPTEL online course on water and wastewater treatment. We are in week 6 right now. And as you all know, the course instructor is Dr. Bhanu Prakash, and he is a professor from IIT Roorkee. And I am one of the teaching assistant. My name is Akash Saha, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I'm pursuing my PhD in environmental engineering. So, if you see this week's content, it comprises basically from phosphorus removal, where we looked into the various how biologically phosphorus is removed from the system, and also we saw the chemical precipitation method. And then we learned about the secondary clarifiers and few points about the attached growth system. So in secondary clarifier, we saw the components of it, the types of settling, the design criteria. And for attached growth processes, we looked into the trickling filters, the rotary biological contactors, and the moving bed biofill reactor. And then we moved largely into the disinfection, where we saw the various chemical kinetics of disinfection and how it works in a plug-full reactor, and the various components and the methods. So we started with chlorination. We saw those redox reaction, how the acid-base equilibrium is formed, what is the role of hypochlorites and chloramines, and then we moved into the various disinfection byproducts. And we also saw the method for ozonation and UV disinfection. So this was the brief overview of this week's lecture. So we will directly go into seeing the multiple choice questions, and in between I also have some numerical questions. So we'll start it. So here the first question says that which of the following is not an advantage of biological phosphorus removal over the chemical precipitation method? So we have to tell that which is not an advantage of biological phosphorus removal, and the options are low chemical consumption, low sludge production, high phosphorus removal efficiency, high chemical consumption. So these are the four options. Maybe you can think over a minute and try to answer. Uh, so today we have already started with the session. So this is just the first question.
Is it low sludge production? I'm not sure.
Okay, we'll see what others are saying. So we have to think in terms of chemical precipitation method. Like, what is the problem with chemical precipitation method? So what is the problem with chemical precipitation method? So if we see the chemical precipitation method, uh, the main problem is the high chemical consumption. So in biological removal, there is no chemical consumption. We are totally based on the removal capacity of the phosphorus accumulating bacteria. So with the help of that, we remove the phosphorus. Whereas in the case of chemical precipitation, we use various kinds of chemicals to remove or to precipitate the phosphorus. So the main disadvantage of chemical precipitation method is the high chemical consumption. Okay. So this was the thing. I'll move on to the next question. Now it says that the steps for breakpoint chlorination are given below. So you have to arrange it in correct sequence. So it says destruction of chloramines and chloroorganic compounds, formation of chloroorganic compounds and chloramines, destruction of chlorine by readily reducing compounds, and then formation of free chlorine. So there is a breakpoint chlorination curve, and there are four different processes or four different stages, if I say. So we have to arrange them in the correct sequence, like which happens first and then the later. So you have to choose the correct sequence. Just try to picturize the breakpoint chlorination curve. and answer the question, then we will discuss it.
B.
Sorry,
B.
D. Option
B. B.
D.
B. B for Bombay.
B, B, B. Okay, okay, okay. Yeah, yeah, I think it's correct. So, so what really happens is we will see the answer. The answer is B, as you have rightly pointed out. And if we see the graph between the chlorine added and the chlorine residual, that is from where we find out the breakpoint chlorination. So what happens is that at first there are some readily reducing compounds are present in the system. So because of that there is a destruction of chlorine. So at first there will be no residual chlorine at first. Now when the reducing compounds are all destructed the initial chlorine amount, now you are adding more and more chlorine. So now there will be formation of some chloroorganic or compounds or some chloramines we say. So there we can see a rise in the curve. So there is some combined residual and till the point C, which is shown in the graph. And after that, there is the destruction of the chloramines and the chloroorganic compounds. So then the graph again goes down, and we reach the point D, which is termed as the break point. And from the breakpoint, we can see there is a linear rise. So whatever chlorine we are added, it uh, turns out to be the residual chlorine. So there is free and combined chlorine from that point. So it will be a linear curve from that. So in that way, there will be a formation of free chlorine.
Excuse me, I have one doubt.
Yeah.
After point B, how can it be combined? Because combined is already finished, isn't it?
No,
After
I think
D,
it is
whatever
free.
chlorine is being added,
Yeah,
that is only
suppose
free again.
no, no. So the thing is, like whatever the chloroorganic compounds are formed till point C, maybe not all of them has been destructed. Okay,
Right,
may,
right.
not all of them. So there may be some part of combined residual still present at point D. Okay,
That is already which is present, not
that is
because
all.
of more.
No, no, now it is already present. So we can see that at point D, it is there is some part in the y-axis up to point 1 maybe point 0.1 ppm. So that is the combined residual. And after that point, if we keep on adding more and more chlorine, that will be the free chlorine. That is the free
Correct,
residual. Okay.
correct.
So some part will be which is already present from the previous points. So this was basically the second question about the correct sequence. So first, there will be destruction of chlorine by the readily reducing compound. Then there will be the formation of chloroorganic compounds and chloramines. Then there will be some destruction of this chloramines and chloroorganic compounds. And then there will be the formation of the free chlorine. So these are the four stages. Okay. Now next question, it's a true false direct question. The mechanism of UV disinfection is that it disinfects by directly damaging the nucleic acid of the pathogens. So you have to say whether it's true or false. It's a direct question.
True.
Yeah, so it's a very direct answer. So we can say that the UV disinfection works by directly damaging the nucleic acid of the pathogens. So this question is true. So very direct and simple question.
Uh, I have one question.
Yeah.
Does this UV disinfection leads to free radical formation, hydroxyl radicals formation?
So yeah, in some cases there because earlier there are some ambiguity whether it forms or not, but now like people are finding out that some radical formation is also there because of UV.
Because in
Okay.
one of the lectures, professor has told that these radicals are formed during US disinfection.
Yeah, yeah, yeah. So now people are more and more research has been done, and it has been found out that some radicals are also formed due to this UV. Okay.
But in our domestic, we use UV radiation for
Um,
these
yeah,
ROs also.
but these
So,
radicals are very short-lived. Very short-lived.
oh, right, 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 right.
Okay, so if you see the half-life of these radicals, they are very short. So that's the thing. Anyway, so we'll move to the next question. So it says that what is the main purpose of using chloramines in water treatment? So is it to remove the iron and manganese? Is it to provide a longer lasting residual disinfectant? To remove the phosphorus? To remove the sulfur? Or to remove bacteria and viruses? So what is the main purpose?
To provide a longer lasting residual disinfectant.
Yeah, so anyone else would like to answer? Any other thought process or any other uh, option do you think is correct? Okay, so basically it is the only the correct answer. So option B is only correct because we have it helps to provide a longer lasting residual disinfection. So whatever we see, the residual chlorine that is present due to after the destruction of these chloramines, some part will be residual. So this will be helping in to give more residual disinfection for a longer period of time. Okay, so option B is only correct to provide a longer lasting residual disinfectant. So this was option question 4. So these questions are very simple, so that's why I'm moving very fast. If you have any doubts in at this, you can ask me or write it in the chat box.
But can't we write both the options? I mean B and can you go
B
back
and
to
E,
repeat it?
maybe yeah, we can. What you are saying, maybe you can say that B and E both are correct, right?
Mm,
Yeah,
mm.
so but the main purpose of these
Oh,
chloramines are to for longer lasting. Maybe it is disinfectant, but the main purpose is for the longer lasting because
right.
this removal of bacteria can be due to the flea chlorine also. But
Yes.
uh, as we all know that HOCl and all it varies with the pH and everything. So for longer lasting, we need the chloramines. Anyway. So the next question, we have to select the correct options regarding the advantage of a trickling filter. So it says that a trickling filter can withstand shock loadings. Nitrogen removal efficiency is very high. There is no odor or fly nuisance. And D, it's a simple operation. You have to find out the correct option for the trickling filter. So can it withstand shock loading? Is the nitrogen removal efficiency very high? Or is there no
All the
odor?
options seem correct.
All
All
the
the
options,
options seem correct.
all the options are correct. No,
All the
please.
options seem to be correct.
Uh, it is not so actually. So first of all, that due to trickling filter, there will be some order and file usage because what is happening because the media is there and over that biofilm is growing. So there will be definitely some fly nuisance because all this will attract the flies and all, and there will some be order also. So option C is definitely not the correct option. And about nitrogen removal efficiency, no, it is not very high. So nitrogen removal efficiency because we have to provide both aerobic and anaerobic zones for the complete nitrification and denitrification to happen. So nitrogen removal efficiency is not very high. So we can
We are providing extra surface
sorry.
for the micro. We are providing extra surface area
Yeah,
also.
yeah, surface area is there, but for complete nitrogen removal, if we are so there should be complete nitrification and then nitrification. So both aerobic and anaerobic zones properly segregated, it should be there. Then the proper nitrogen removal will happen from the system. So that is not the case in the case of drifting filter, but we can say that it can withstand high shock loadings because the biomass is retained for a longer period of time in the system before it gets slugged off. So it is a very high amount of biomass is present for the removal of or the decomposition of this organic matter. So it can withstand shock loadings and it's a very simple operation. We can treat it as a filter That's why it's a trickling filter it is called. So very simple. We have to just for biomass or biofilm growth, it will take more and more time. But once it is acclimatized and it is giving removal, then it's a very simple operation. So both A and D options are correct, we can say. So a trickling filter can withstand shock loading and it has a simpler operation. Whereas option B and C is not true for the case of trickling filter. I hope it is understandable. We will move to the next question. Okay, so it says that what is the correct sequence of formation of the following compounds during chlorination of water in which ammonia is present? So in my system, if some ammonia is present and I am adding chlorine into the system, so what will be the different compounds and the order in which they are formed? So you have to find out. So please try to answer this question. So the first compound will be the compound which is forming first with the reaction of ammonia.
It's B.
Option B.
Yeah.
Okay. Anyone else? Please, these are very simple problems. You can just type it in the chat box if you are not feeling comfortable in unmuting yourself or and speaking out. So just give a try. There is no one to judge you here, and we are not so many people are present also. So you can give it a try. Or if you have any questions, you can ask. So, rightly pointed out, option B is correct. So, we will see how these compounds are found. So, we can see if chlorine is added, then we basically find that HOCl or hydroprocess acid is present. So, ammonia after reacting with that HOCl, it will first form NH2Cl. One of the hydrogen will get removed and some chlorine will get added. So it is NH2Cl. Then again it will react with HOCl. So again one more chlorine will get attached, removing one hydrogen. And then again after reacting with HOCl, we can see NCl3. So this is the final product. After that, no chlorine can be added in the system. So the correct sequence is NH2Cl, NHCl2, and then NCl3. So in that way, these compounds during chlorinations are formed when ammonia is present. So the presence of ammonia is mandatory. If ammonia is not there, these compounds will not be formed. Definitely, it will be HOCl and OCl minus only. So this was the sixth question. I hope everyone is comfortable with it. So we'll move to the next question now. Okay. So it says that which of the following is not an attached growth process? So we have seen different kinds of attached growth process. So we have the five options as trickling filter, MBBR, which is the moving bed biofilm reactor, SBR, sequential batch reactor, RBC, rotatory biological contractor, and ASP, activated sludge process.
ASP.
ASP, anyone else? So I have to find out which one is not an attached growth process. Option C, Prashant is saying SBR. So yes, both the answers are correct. So in this SBR, which is a sequential batch reactor, which is a modified process of ASP, kind of, in which all the reactions are happening in a single reactor, one by one simultaneously. It is a sequential batch reactor. Uh, can someone tell me what is the modified process if we want to make it attach growth in sequential batch reactor? How we can how we can make it attach growth? So we know that SBR is not an attached growth process, but how can we make it an attached growth process? Simple SBR. Can someone tell me like if ASP is there? Now ASP is not an attached growth process; it's an simple suspended growth process. But what is the modification of ASP as attached growth process? The answer is there in the options. So in an ASP aerator, if we add some media, some moving media like polyethylene or something like that, so it becomes a moving bed bioreactor. So same SBR will also can become SBBR, sequential biofilm batch reactor. So like that, we can just add some media, some plastic media or something, and make it as an attached group process. Okay. So both, so for this question, SBR and ASP are the correct answer. Okay. So we'll move to the next question. So now it says that select the correct statements regarding disinfection and its method. So what we can say is ozone forms residuals in disinfection process. The disinfection efficiency of chlorine decreases by increasing the contact time. Turbidity affects UV's removal efficiency, and ozone requires relatively shorter contact time than chlorination. So which of the options are correct? Yes, option D. Anything else?
And C is also correct.
Option C, right?
C and D both are correct.
C and D. So yeah, as you have rightly pointed out, both options C and D are correct. Okay. So whereas if you see the disinfection efficiency with chlorine, it increases with increasing the contact time. And turbidity definitely affects the UV removal efficiency because some part will be used up by the turbidity or the suspended particles. And then if ozone is there, it requires relatively shorter time than chlorination. So it is also correct. So both options C and D are correct. Okay, so now we'll move on to a small numerical. Please take out a pen and paper and calculator to solve it. So it says that a disinfectant solution is used to inactivate a certain microorganism with an initial concentration of 2.5 into 10 to the power 7 CFU per ml. The inactivation rate constant K is determined to be 0.03 per hour. How long does it take to reduce the organism's concentration to 0.5 into 10 to the power 5 CFU per ml? So there is some
What is
initial,
CFU? What
sorry,
is CFU? CFU.
CF, yeah, CFU is called as colony forming units. So whenever we are trying to estimate or measure the amount of organisms present, we do it in terms of colony forming units. Okay, so how many colonies these bacteria are formed per ml of the sample? Okay, so it says that per ml of the sample it has the capability to form 2.5 into 10 to the power 7 colony forming units. So we do it in a petri dish actually by giving some nutrients to the these microorganisms. So if the microorganisms are present on the petri dish, we can see spots of these microorganisms, the colonies, as we can say. So hence it is measured in terms of colony forming units. Okay, so the initial concentration is given, the final concentration is also given, the K value is also given. So you have to find out the how long it is taken. So basically it's a direct formula and we have used this formula quite a number of times. Maybe in some other form, but it is the same formula. So please try to find out the answer. We'll see how to solve it. Okay, so maybe I'll solve this problem. Okay, so if you see the first problem, the initial concentration was 2.5 into 10 to the power 7 CFU per ml, and the final is uh, 0.5 into 10 to the power 5 CFU per ml. So if we use the Chick's law, it is nothing but the first order degradation. So we know the first order degradation curve, that is Ne is equal to N naught e to the power minus kT. So we are using this in the BOD equation everywhere. So first order degradation, Ne is equal to N naught e to the power minus kT. So we know Ne 0.5 into 10 to the power 5. We know N naught 2.5 into 10 to the power 5 into 10 to the power 7 into e power minus k. K is given as 0.03 and it is in hours. So my final time will be also in hours. So if we calculate the time, it will be equal to 207.15 hours. Maybe equal to some 8 to 9 days it is taking. Okay. So I hope it is very clear. So just and it is basically called as a Chick's law. So this equation is nothing but the Chick's law to find out the uh, whatever, maybe time or rate constant or final of rate concentration. So the answer is Chick's law. So here is the solution. Whatever we did. Okay, so we'll move to the next problem. It says that now it's basically acid-base equilibrium. So it says that the pH of a solution after adding an acid is around 4.8, and the pK value, the dissociation constant, is given as 3.86 for the acid. Okay, so the pK value of the acid is given, and we have the pH of this acid of the solution after adding the acid is given it as 4.8. Now, if the concentration of the deprotonated form, so now from Ha it will change into A minus and H plus. So the A minus uh, concentration is 10 raised to minus 3.2 molar. Then the concentration of acid at equilibrium is. So at equilibrium, we have to find out the concentration of acid. So we don't know the acid concentration. So can somebody tell me like which formula can we use? I will also derive the formula for you if needed. So if you know the formula, you can directly tell me, then we can see how to solve this problem. So here in this system, we have water and acid. So once these two are added, the pH of that system is found out to be 4.8. Now the deprotonated form, the A minus ions, is 10 raised to minus 2.3. And you have to find out that what is the concentration of acid at equilibrium. That's it.
That means H plus ion concentration is also the same because Ha will ionize to give H plus ion and A minus ion. So
Yes,
whatever is the
yes.
concentration of A minus ion, same will be H plus ion. Am I
No,
right?
let's see. What you are saying that at equilibrium.
Whatever is the concentration of A minus, that is 10 raised to minus 3.2, the same should be for H plus as well.
No, we are finding out the concentration of Ha, the acid at equilibrium. The pH is already given. Okay, the pH is already given. So basically, okay, I'll try to solve the problem. So suppose this is HA, this is a monoprotic acid. Monoprotic acid, like for example, we can say HCl. Okay, HCl. So what happens is when HA is there, maybe it will be dissociated into H plus and A minus. Okay, so if we see the dissociation constant Ka at equilibrium, it will be the concentration of H plus, concentration of A minus divided by the concentration of the acid HA. So this will be my case in equilibrium, and we are considering ideal situation, ideal solution. Okay, so hence we are ignoring the activities and we are taking the concentration. So now what we can do, we will take H plus at one side and we can write KQ into HA divided by A minus. So now we will take negative logarithm at both sides. Okay, so minus log H plus, we can write it as minus log H plus minus log minus log KQ, and then plus we can write minus log HA, and this will become, since it is in denominator, it will become minus of minus log A minus. Okay, so minus log H plus, it is negative logarithm of H plus ion is known as pH. So you can write directly as pH, and the negative logarithm of dissociation constant is known as pKa. pKa. So plus we can write this negative log, the extreme can write it as log of A minus divided by the minus sign will become as the denominator HA. So this is my equation. Okay, and this equation is known as Henderson-Hasselbalch equation. Is it clear? So nothing, we just have to take one monoprotic acid. We know that it will dissociate at H plus and A minus, and then the equilibrium constant will be equal to the product of the products, and then the divided by the reactant concentration, and then after arranging and taking the negative logarithm at both sides, we will get this equation. So we can also write it as pH is equal to pKa plus log of, now A minus is the proton acceptor, because A minus can accept a proton. So we can just write it as any proton acceptor divided by the proton donor, because HA can donate a proton and A minus can accept a proton. Okay, so we can write it in this form also. So similarly, we will see how to solve that problem. What was the problem? So here in the problem, the pH value is given as 4.8. The pK value was given as 3.86. So it will be plus log of. Now the concentration of A minus is given 10 raised to power minus 3.2, and HA is not known. Okay. So my HA concentration will be equal to 7.244 into 10 to the power minus 5 molar. So I hope it is clear to all of you. Anything to be repeated again, please let me know. Shall we move forward, or I should explain it once again? Hello, am I audible?
Yes, audible.
Okay, okay, then we'll move forward. I hope it was easy. Okay, so same. This is what directly shown in the derivation of this problem. So this is Henderson-Hasselbalch equation. So directly we can substitute and get the answer. Okay, so next problem. It says select the correct statement regarding phosphorus removal. So phosphorus removal efficiency improves if nitrate concentration is higher in wastewater during anaerobic stage. Next, phosphorus can be removed from wastewater by ferric chloride addition. Phosphorus uptake is there during the aerobic stage and released during anaerobic stage. And fourth, biological phosphorus is removed by promoting phosphorus accumulating organisms by providing them alternate anaerobic and aerobic conditions in the treatment plant. So which of the statements are correct?
P and D.
C and D or B and D?
Uh, P and D.
B and D, right? Okay, so yes.
P
So
and D.
option
P and D.
no, C and D both cannot be correct, right? Either of one can be correct.
But phosphorus uptake is there during the aerobic stage and released during anaerobic.
No, is it the aerobic stage or is it the anaerobic stage?
No, it is taken up during aerobic and released during anaerobic.
Uh, no, actually, at first there should be anaerobic stage and then aerobic stage. So,
No, no, but phosphorus is taken up during aerobic stage. This is just a rearrangement of words, I think. Phosphorus is taken up during aerobic stage and released during anaerobic stage.
no, I think there is some problem because there are alternate aerobic and anaerobic stage. So
No,
option B
no,
and D.
these alternate are there, but this is correct. That during aerobic it is taken up by the
First, there
uh,
should be an anaerobic stage and then there will be aerobic. Okay. So first anaerobic stage will be there and then aerobic stage. So option D is correct here. I think you might need to check those options again. So you can see the lectures basically. And option B is correct because of the ferric chloride addition. But whereas for phosphorus uptake and then aerobic, so it will be first anaerobic and then aerobic.
I don't understand because we can write this way also. Statement seems to be correct.
Sorry?
This this statement seems to be correct. Whether it is a different matter whether we write aerobic first or anaerobic, but this is correct that phosphorus is taken up by phosphorus accumulating bacteria
No, no, this
during
is
aerobic stage.
no, no. I think see first this uptake happens definitely in the anaerobic stage, and then at the aerobic stage only it is getting released. So statement C is incorrect. The uptake happens in the anaerobic stage. If you see the polyhydroxybutyrate formation and all those things, the uptake will happen in the anaerobic stage. So option C is not correct.
I
Fine.
think it is reversed. I think it is
No, no,
reversed.
please, I think you also need to check it. Whatever, as per my knowledge, first anaerobic and then aerobic. Okay, please go through it
No,
because it
no,
would,
no. My question is only thing is
yeah,
whether the phosphorus is taken up by bacteria during aerobic stage or anaerobic. It is taken up
anaerobic
during
stage.
aerobic.
Anaerobic stage. No, it is taken up during the anaerobic stage.
But during aerobic stage, they get energy and ADP is converted into ATP.
Yeah, and then it is released
That is
back into the
phosphorus taken
system.
up. Adenosine diphosphate is converted into triphosphate and it is taken up during aerobic stage only. ADP is converted into ATP, right?
That
Then it
is
is phosphorus uptake.
uh, no, I think there is some problem in your understanding. The definitely it will the energy released. during the PHB oxidation, and then it is
Right.
used to form the polyphosphate bond.
Right. Right.
Okay, and then in the cell, and the orthophosphate is removed from the solution. Okay, that is okay. And then this cell growth occurs, and consequently the PHP that is utilized, and new biomass with high polyphosphate storage growth accounts for the phosphorus removal. So as a portion of the biomass is wasted, the stored whatever stored phosphorus is removed as it is disposed of with the sludge. So this what happens in the aerobic stage.
Aerobic stage, there is a release of energy, right? Energy is
See the
produced, and that
whatever
is convert.
whatever whatever PHB is metabolized. Okay, the stored PHB, the polyhydroxybutyrate
Right.
butyrate is
Right.
there. It providing energy from oxidation and carbon for new
Right.
cell growth. Okay,
And that
and
energy converts ADP into ATP,
this
isn't it?
energy, yes, this energy is released during the PHB oxidation. The energy is released
Mhm.
during the PHB oxidation,
And
and
that
then
is
it is
during
used.
aerobic.
And yeah, that is during aerobic. So everything,
Aerobic.
all this happening in aerobic zone, and that whatever the it is getting released, that is wasted with the help of this biomass, is happening in the aerobic zone. Whereas all the PHB formation, whatever the PHB formation and the uptake is there, it is there in anaerobic zone.
PHB formation takes place during anaerobic,
Yes,
right?
that is so uptake is there.
That is being oxidized during aerobic
Yes,
with oxygen, obviously with
yes,
oxygen.
yes. So
And
so
that
it is or
energy
aerobic.
released
So that is
aerobic.
aerobic. Yeah,
And,
that is aerobic.
and that energy is stored, that converts ADP to ATP.
Yeah, that is also
So
uh,
that means uptake of phosphorus is there during aerobic stage.
no uptake is not there.
Diphosphate is,
Release is there. So I think there is we can
I
go on.
doubt, I
Maybe
doubt.
okay. We will discuss it maybe at some later. For the interest of others, we will move on to the
Right.
next question. Okay, okay.
Uh,
Maybe we can
Please
take up this later.
confirm it
Yeah,
whenever it
I
is
will
okay.
I will give you all the proper steps. I will give you the
Right. Right.
complete steps, and then we can maybe discuss.
Okay.
Okay. So the next question it shows that in a trickling filter system, the biomass in the interface of biofilm and the media surface undergoes. So what kind of respiration happens at the interface of the biofilm and the media surface in a trickling filter system? So here what happens that at the interface of the biofilm and the media surface, the enough oxygen is not able to enter, okay, by penetrating, because slowly the thickness of biofilm will keep on increasing, and enough oxygen will not be able to reach at the interface of the biofilm and the media surface. So what happens, there an anaerobic zone is created, and because of that, and also at last, since less food is also present in the inside at the interface, so at that place it will reach to endogenous phase. As we all know the bacterial curve, so at the interface there will be some endogenous respiration. Okay, so because of that, the sloughing will happen. So here option B will be correct. Okay, so again I am trying.
What is
Hello.
exogenous respiration?
See, endogenous is what is happening within the
Exogenous.
cell
Exogenous.
within, and exogenous is what is happening
Okay.
outside the
Okay.
cell. Okay.
Okay.
So here endogenous respiration will happen. They will feed on to each other, and also there will be an anaerobic condition. So this is about the 12th question. We'll move to the next question. The disinfection efficiency of hypochlorous acid in treatment uh, is not dependent on pH value, increase with increase in pH value, remains constant at all pH value, or decreases with increase in pH value. So we have to think about the activity of this hypochlorous acid with respect to pH. So what happens actually?
It will increase with the. Um,
Will it increase with pH?
no, no.
No. So basically what happens is
It
it
will
decrease with the increase in pH.
decrease with the increase in pH
Increase in
level.
the pH. So option D is the correct option. So disinfection efficiency will decrease with the increase in the pH. And the best pH range for hypochlorous acid to be active is 5 to 7. After that, the activity will tremendously decrease. Okay, so option D is correct. Now next question, which of the following chemical is not used for phosphorus removal using chemical precipitation? So here we have four chemicals: lime, caustic soda, ferric chloride, and alum. So which of them is not used for phosphorus removal? So here if you see, all of lime, ferric chloride, and alum is used, whereas caustic soda, which is basically NaOH. NaOH is not used for phosphorus removal because uh, for precipitating we need lime or ferric chloride or alum. Okay, whereas NaOH is not going to precipitate for the phosphorus during the chemical precipitation. So the correct answer is caustic soda. The next question. Okay, so it says that select the correct statement. The disinfection efficiency of chlorine increases with decreasing the time of contact. During chlorination, only trihalomethanes and haloacetic acid can be formed as DPBs, that is disinfection byproducts. Ozone needs shorter time contact for a range of pathogens and does not form harmful byproducts in the presence of bromide. Turbidity has no effect on UV's removal efficiency. Ozone is more lethal than UV in clearing the protozoa Giardia. So which of the options is correct? So out of these five statements, only one statement is correct. You have to find out which one. I'm making it easier for you. So if we see the first statement, it is definitely not correct because the more the contact time, the more efficient will be the disinfection. So option A is incorrect. Then during chlorinations, not only trihalomethanes, all kinds of methanes or more different various kinds of disinfection byproducts can be formed. So option B is also not correct. Then option C, it is that it will produce some harmful byproducts in the presence of bromide. Okay, so that it does not form, it is incorrect. And then option D, we have seen it before, that turbidity will have some effect. So only option E is the correct answer. That it will be more lethal than the UV in killing the protozoa Giardia. So it is very specific kind of, we have to memorize it. So option E is only correct here. Other rest of the options are incorrect. Okay, so we will solve one more last problem. I think this one because rest we have already seen. This also we have done. Okay, we'll see how to solve this problem. This is regarding the phosphorus, biological phosphorus removal. So we have to find out, we have to estimate rather the amount of phosphorus that is being removed from the system. So we have a nice numerical for that. So calculate the P in the filtrate and the total P in the treated effluent. The COD is 300 milligram per liter. The BCOD, the biological COD, or we can say that the BOD is the 200 milligram per liter. The BSCOD, out of the BOD, whatever is biologically biodegradable and soluble, so it is a soluble COD, 50 milligram per liter. The phosphorus present in the system is 6 milligram per liter. And then some rate constants are given, the YT value, KD value, and theta C. And then the P content in phosphorus accumulating bacteria is 0.3 gram phosphorus per VSS. And the P content in the other kinds of bacteria is 0.02 gram per VSS. And the effluent VSS is 8 milligram per liter. So you have to find out how much will be removed, how much will be in the filtrate, and how much will be the total treated effluent. Okay. I hope you have noted down or taken a screenshot. We will see how to solve it because this is a very nice question. We can get to know that how this phosphorus is removal can be found out. Okay. So first, what we have to find out, we know that the COD here is 300 milligram per liter. Now BCOD, as I have told, the biodegradable COD, or okay, so it will be 200 milligram per liter, and the BS, this is the soluble COD, biologically degradable soluble COD, that is 50 milligram per liter. Now YT, KD, theta C, everything is also given. So first we will find out the Y observed. Okay, Y observed we will find out for what is the formula, that is YT divided by 1 plus KD theta C. So Yt is given as zero point 0.4 and 1 plus KD is 0.08, theta C is 5. So we will get as Yt as Y observed as 0.28 because we will require this. So now we have to find out like how much uh, bacteria will be formed. So first we will find out the phosphorus accumulating bacteria, that is PAB, phosphorus accumulating bacteria. So PAB produced, how much it will be yield into the food available. So what is my yield? Yield is YOB, and what is my food? Food will be my S. S, or I should write as whatever biologically soluble COD is formed is there. Okay, so PAB will be formed based on my biologically soluble, biodegradable soluble COD. So my YOB is 0.28 into 50, so it will become as 14 milligram per liter. So this is my BSCOD. And what about the other heterotropic bacteria? So heterotropic bacteria, the other bacteria that will produce will be equal to YOB into, now whatever BOD is present, that is my BCOD minus BSCOD will be used by the PAB. So this is my assumption that BSCOD is used for my PAB and the rest will be used for other heterotropic bacteria. So it will be 0.28 into 200 minus 50. So it will be around 42 milligram per liter. Now, in the question, it was given that how much phosphorus will be accumulated by PAB. It was given as zero point 0.3. So, what is the phosphorus accumulated by PAB? It is zero point 0.3 into the bacteria produced. So, 14 milligram per liter is produced. So, zero point 0.3 into 14, it will be 4.2. Okay, 4.2. And what about 4.2 milligram per liter? And what about the other bacteria? P in heterotropic uh, bacteria, it will be equal to my the coefficient was 0.02, so 0.02 gram per VSS into my 42. Okay, so it will be 0.84. So this will be the phosphorus accumulated uh, in my heterotrophic bacteria. I think this is not milligram per liter. This is okay. So 0.84. So the total, what is my total P accumulated? So my total P accumulated will be 4.2 plus 0.84. It will be equal to 5.04 milligram per liter. Okay. And what will be my in effluent? So the total P in the system was 6. So 6 minus 0.4 milligram per liter. So it will be around 0.96 milligram per liter. So directly we can find out. Okay, so what we have done is first we have calculated the Y observed. So what was my uh, yield observed from the total yield, and then we will find out like how much phosphorus accumulating bacteria is produced. Okay, in terms of YB into BSCOD, because that is directly soluble in the system. So we'll find out the PAB produced, and then we'll find out the heterotrophic bacteria produced. That is 0.28 into 200 minus 50. So whatever is leftover biological COD is present. So that we will use, and then we'll find out how much phosphorus will be accumulated in the phosphorus accumulating bacteria, and how much will be present in the heterotrophic bacteria. So 0.02 for heterotrophic and 0.3 for PAB. And then we will find out the total and then subtract from the total phosphorus present in the system. So my effluent phosphorus present will be 0.96 milligram per liter. Okay, so easily we can find out this answer. I hope it is clear. We'll move to the next problem. Okay, so maybe we can solve this problem also. Like it is saying, find out the pH of a system when HOCl dissociate at equilibrium. Okay, and the HOCl consideration is given and the pK value is also given. So it's a direct question. We can find out the answer. Find out the pH of the system when HOCl dissociates at equilibrium. The HOCl concentration is given and also the pK value is also given.